Alright, so for the second sample problem about current mirrors, so here is the circuit, and here is the circuit from the last sample problem. So it is just simple with the values given, but here on the second sample problem, there are no values given, but the components are shown and they are labeled properly. So here, we can see that there is a VCC, the RX, the IX, the Q1, IE1, IB1, IB2, IE2, Q2, and the IL. So naming this different components, so as shown here, the IE1 stands for the emitter current, the IB1 is the base current, the IL is the current at the load, and these ones are the current and the resistance shown in here. So the difference between these two is that the Q1 and the Q2 are mirrored. So in order to solve that, we are going to assume that the value of the VCC is 10 volts and the RX is at 1 kilo ohms or 1000 ohms. So to solve that, since we have the value of VCC and RX, the next step we're gonna do is to know what is the formula of IB. So we're gonna take first the IB1. But um we can also take IB2. It's the same because they are just mirrored with one another. For instance, for this example, we're gonna use the term IB1. But nevertheless, they are both the base currents. So for the formula for the IB is IE. So since we use the IB1, we're gonna use the IE1 as well so that we have uniform values. So IE1 is all over beta plus 1. So we know this formula from the derivation from the IB, IC, and IE. So this will be our formula. And this one is approximately the same to IE1 all over beta, since plus 1 is only the addition. So, nadagdagan lang siya ng isa. So, ayan. Ito yung formula natin for the AB1. Then, since it is mirrored, so we can assume that the value of IB2, is approximately IE2 all over beta. Same as this. So we can assume that since they are just mirrored with one another. That's the good thing about current mirrors. We can assume that they are at the same value since they are mirrored. But we must take into consideration that they are mirrored properly so that we can take the formula itself or take the formula from one another. But if they are not mirrored properly, there are instances. So we will derive formulas from that. So once we know, since we know the value of IB1 and IB2, we can now assume that the value of VBE1 is also the VBE2 since they are mirrored. And we're gonna use this value later. So proceeding, we're gonna go to the next panel. So next one, since IB1 is equal to IB2 shown on this previous part, IB1 is equals to the value of IB2. We can assume that IB is equal to them. So, equal sila pare-parehas kasi equal naman eh. Diba? So, next na value na meron tayo is the IE. IE1 and IE2. So, same lang dito. IE1 is equals to IE2 then they are both equal to the emitter current. So once we've known the emitter current, next thing we're going to do is we're going to get the value of this one, the Ix. So, do you still remember the formula earlier, the I control? So if you remember the I control or the I, and this is also the mirrored current, so the formula for that one is VCC minus VBE over the resistance, right? If you remember the previous problem earlier. So that is the formula for the mirrored current. Now, since this is labeled as the Ix, we are going to just change the nomenclature or the naming. So Ix is just equals to VCC minus VBE all over the Rx, since the resistance has a subscript of X. So just the same. This is still the mirrored current. I mean the I control. Same formula. So what we're going to do is take this value, take the value of VCC, which is the 10 volts, minus the VBE, which is we know that it is 0.7 volts. That's the universal value of VBE. Then all over 1 kilo ohms. So 1 kilo ohms Rx. So now we're going to calculate the value. Then we will get the value of 9.3 milliampere. So that is our value. Yeah, value right there. Then what we're going to do next is we're going to get the value of the mirrored current with Ix. The mirrored current of Ix. What can we notice here? Okay. Before we calculate the final answer, what do we notice here? So Ix is mirrored to IL. So that's is mirrored current, right? So notice that we got the value of IB1, so it is equals to IB2. The IE1 it is equals to IE2 since they are the current mirrors. So watch this. Ix, what is the mirror? IL. So basically, the value of Ix is equals to the value of IL. So Ix has the value of 9.3 milliamps. Therefore, okay, we're gonna use green pen for this one. So, therefore, IL is equals to Ix. Then IL is also equal to 9.3 milliamps. So that is our final answer, and we got the current mirror. All right.